Okay, when you have a hanging mass, anything that's hanging and being repulsed is going to be an equilibrium question. So this actually becomes a little bit easier of a question than it appears. There's a few things that we need to do. Well, first of all, we need to add in things. The sphere charge of minus is placed near a 3 gram. That's minus. Okay, so they're both minus. So this one's minus and this one's minus. This one is 0.6 microcoulombs and this one is 0.4 microcoulombs. We also know that this is 10 degrees, and we know that that is, 4.5 centimeters, which is 0.05 of a meter. And let's see what else we know. Well, we know that if this is 0.3 of a gram, then it's going to have a force downward due to gravity. That's Fg. It's also going to have an upward force opposing it because it's in equilibrium. That's going to be Ty. And we also have some x forces. You're going to have just plain old repulsion between these two, which I'll call force, and you're going to have your tension in the x direction. So there's your tension. If you look at this triangle, if this is 10 degrees, then that's got to be 10 degrees. So I've got a nice right triangle created. I've got my colors in there, and the first thing I'm going to do is figure out the force, and then the second thing I'm going to do is figure out the length of this thread. So let's see here. I know that my sum of my forces in the x direction has to be equal to 0, which means that my force minus my tension in the x direction has to be equal to 0. And I know that my sum of my forces in my y direction also have to be 0. So tension in the y, subtract force due to gravity, equals 0. So I'll start off with my sum of fx's. I'm just going to set these two things equal to each other. Force equals tension in the x direction. I got to figure out what tension in the x direction is relative to tension. So usually you see the x and you go tension in the x direction, that's t cosine of 10 degrees or whatever your angle is. But notice that this 10 degrees is off of the y-axis. So you can draw this out and go, well, that's got to be 80 degrees. And then you notice that this ty would actually be here. Ty. And then this tx would actually be here, which means then that if I'm going to have off of the x-axis, I'm going to have to go, my force is going to be equal to t cosine of 80 degrees, not 10 degrees. If you do 10 degrees, you're just going to get it wrong. Okay, that's my sum of my fx's. Let's go to this one. Tension in the y direction is equal to force due to gravity. Well, I know that force due to gravity is mass times gravity. So my tension in the y direction is going to be t sine of 80 degrees, still 80. And then my mass is 3 grams, 0.3 grams, sorry, which is 0.3 divided by 1,000. That's 3 times 10 to the minus 4. And gravity is 10. So I can find my tension directly here. 3 times 10 to the minus 4, 10. Over sine of 80. Make sure you plug that into your calculator properly, and when you do, you'll get a tension value of 3 times 10 to the minus 3 newtons. I'm going to take this tension, I'll put it right here for that tension, and I'm going to get my force, which will be my answer to part A, right up there. So that'll be 3 times 10 to the minus 3 cosine of 80 degrees, which ends up giving me 5.29 times 10 to the minus 4 newtons. Okay, so there's your force of repulsion. So I guess I should say maybe that this is to the right, but it is action reaction, so you could say it's to the left. But based on my diagram here, I'm going to say it's to the right. That's part A. Part B is actually much easier. It's the length of the thread. I've already got my triangle figured out here. This is the length I'm dealing with. I've got 10 degrees here. I know that this is 0.045. Here, let me redraw this for you. This is 0.045 of a meter. This is 10 degrees, and I want to know what this is. So that's just sine, opposite over adjacent. So a sine of 10 degrees is equal to 0.045 over L, which means your length ends up being 0.045 over sine of 10, which is 0.26 of a meter. There you go.